Hello and welcome to episode 42 of After the Reach podcast. We're your hosts, Jeff and Sarah, and I'm super excited for today's guest, Professor Trevor Branch from the University of Washington's School of Aquatic and Fishery Science. He's here to chat with us about a couple papers that were published just earlier this year, delving into the land of blue whales. Jeff, I'm super excited about this. How about you?
Super excited to talk about blue whales and the idea of fight club and flight club.
Yeah, so we're going to be talking about two papers. The first one is most flight baleen whale species are acoustically cryptic to killer whales, unlike fight species. So that's that fight club versus flight club. And then Trevor also published another paper called Timing Hypothesis Explains the Mystery of the Missing Blue Whale Calves. And super excited to kind of delve into both of these and learn some more about blue whales. I love them and don't know enough about them. I think they're kind of underappreciated. So happy to welcome to the show Professor Trevor Branch. All right. Well, thank you so much for joining us today. We're so excited to talk to you about these papers that you've recently put out. I was so fascinated. I actually read them on my flight back from Australia in February. So one of them was kind of about the flight or fight species and how they, vocalize cryptically or not cryptically. And we think that's in relation to killer whales and predation and that kind of thing. So, if you want to just introduce yourself first and kind of let our listeners know who you are, and that would be great.
I am Trevor Branch. I'm a professor at the School of Aquatic and Fishery Sciences at the University of Washington. And I am a theoretical ecologist or a modeler. I come in with a background in computer science, and I do a lot of math and stats, and I pull together a lot of data from a lot of different sources and try and figure out what is going on, basically trying to solve biological problems using math and stats and computer coding.
Awesome. And this particular study that you put out recently or published on recently, how did this kind of come into being? Like, what inspired this? It was so fascinating to me and to Jeff. And is there something that sparked this particular kind of interest?
Yeah, I'm trying to write a book on blue whales. I've done a lot of research on blue whales, and I spent last year basically finding and reading as many papers and books as I could on what has been done on blue whales before. And I was reading through all this, and I came across a reference which said, killer whales can't hear anything below 2000 hertz. And it suddenly struck me that killer whales can't hear blue whales when they call to each other, because blue whales make super, super deep calls that don't go above 100 hertz. Well below this 2000 hertz in the book that I read. Now it turns out that actually killer whales can hear lower than 2000 hertz. That was a bit of a simplification, and this sparked this sudden thought that blue whales can make amongst the loudest calls known in the ocean that are heard for hundreds of miles away, and a killer whale could be right next to them and not hear anything. Which just blew my mind. And I thought, wait a minute, is this true of all the baleen whale calls? And I started digging into it. Of course, as you'll hear in this episode, it's much more fascinating than that. So we'll delve into that in a bit, I guess.
Yeah, and so kind of break it down for us and for our listeners. The paper itself mentions these like fight populations versus flight populations, and of course, immediately I'm thinking like humpback whales are going to be one of these like fight populations, right? We've seen them interact with killer whales. We hear them as well. But can you break that down on what?
And we've seen them be aggressive with killer whales.
Mm-hmm.
Yeah, the fight versus flight story is really, really, really cool. So it's from a paper by Ford and Reeves and back in 2008, where they really laid out that across all of the baleen whales, so you're familiar humpbacks and minkies and blue whales and fin whales and right whales and so on, they really fall into two groups. There's the one group, like the humpbacks, that are maneuverable and they look kind of bulky and they might have knobs all over them. Like think of the humpback, long fins where they have knobs all over them, or they have callosities like right whales or gray whales that look all knobbly all over. And all of these species are super maneuverable, and they're not that fast. They can't swim very fast.
Mm-hmm.
And so all these whales are actually the whales that were targeted by the Moby Dick whalers in the 1700s and 1800s because they were slow. You could sidle up to them in your rowboats and harpoon them, and they wouldn't escape. And it turns out all these whales also, if they're faced with killer whales, they'll stand and fight. They'll fight back and they'll try and smack the killer whales with their flukes or with their flippers. They'll stand and defend their calves. But it's mostly the calves that the killer whales will eat of the big whales. And so those are the fight species, the fight club, as I like to call them, if we're allowed to talk about that. And then the flight species are all the others. So there are these sleek, streamlined whales that don't have knobs and callosities on them. They're basically built for speed, streamlined and beautifully. They all kind of look kind of similar. So blue whales and fin whales, minke whales, Brutus whales that are in this group as well. And their reaction if they come across killer whales is to swim as fast as they can. And if their calf can't keep up with them, tough luck. And if they get cornered, they just abandon the calf and they're like, oh, well, too bad. You couldn't swim fast enough.
Survival of the fittest. Really.
Yeah.
They're not a great model of parents. But they do endow their calves with the ability to swim really, really fast and to grow really, really fast in size so that they can outgrow the window of opportunity that killer whales have the right size to be able to catch.
Sure.
And it also turns out that all these whales, these blue whales, fin whales, sei whales, minke whales, they were not caught by the Moby Dick style whalers. They couldn't be because they swam too fast.
Mm-hmm.
And they sank when you caught them. And so you had to wait for modern steam boats and explosive tipped harpoons and a variety of other innovations that allowed you to catch up to these whales, kill them, inflate them with air so they wouldn't sink. And all these innovations in whaling we call now modern whaling, which basically was the late 1800s, but really came to the fore in the 1900s.
Mm-hmm. That's just so fascinating. I don't even know where I want to go with this because it's just so much to think about, right?
Yeah, and I'm just curious, all the different the types of data that you were able to put together and where the data came from and what you were able to collect for your paper.
Yeah, so unlike traditional field biologists, they'll go out to the field and try and collect data and see what's happening. Because I'm a modeler, my instinct is go and find out what everybody else has done and try and make sense of it. Mm-hmm. And so I spent last summer downloading and reading more than 200 papers on the calls that different species of whales make. And I'd done a lot of work on blue whales, so I was pretty familiar with all the blue whale calls, but I wasn't as familiar with all the other species. And so I tried every region, every population of whale, of each of the whale species to figure out what the core main calling frequency is, what the upper range is, and what the lower range is, and how does that match up to what killer whales can hear. And so that was the data collection, was basically trying to find a bunch of papers, and I would search until I found at least a couple papers in each population that told me what I needed to know, summarize the information, and start looking for patterns.
Interesting. And when you say populations, are you finding any differences within species, but across different populations, maybe in different oceans or regions or that kind of thing? Or is it generally like a speciation, that kind of thing?
Yeah, there are some differences within a species. Blue whales I'm most familiar with. In fact, we define blue whale populations based on the songs they make. We kind of make a distinction between general calls that include everything and songs that are just like in songbirds. Yeah. They're a male produced call that they do that presumably attract females to them. It's hard to believe for some of the species, but it does. And for blue whales, each region of the earth that's occupied by blue whales kind of has a unique, very unique song type that you can use to tell them apart.
Interesting.
And so, if you go to the Antarctic, they make one song type. Go to New Zealand, it's another song type, or California, it's another song type, and so on and so forth. And each of these song types is quite different. If you put a hydrophone, the underwater microphone down, and you listen, you hear the sounds. You might have to speed them up so we can hear them because they're very, very low frequency.
Sure.
Any qualified blue whale acoustician could listen to that and say, "Oh, that's a Sri Lanka call," or that's a call from the population of Madagascar, and even if that call is sometimes thousands of miles away from where you expect to hear it, then they would say, "Well, that's really unusual. I wonder what that lone vagrant whale is doing so far away from its usual place."
Interesting.
And you might hear it for a few hours, and then it disappears, and you never hear it again. But in the call range, you'll just hear them, this volume of calls, going out over and over and over again.
And are the calls pretty consistent over time? Like humpback whales, their songs kind of change over, every year they're changing their songs. But are blue whales specifically, I guess, pretty consistent throughout time, or do they change as well?
Well, this is a completely fascinating thing, and I'm sure there are people out there who know this already, but for me, it was completely fascinating learning about each species of whale and how they call. And some of them, like blue whales, do call pretty much the same call every single year. They, for whatever reason, the blue whales get a little deeper every year.
Oh,
Interesting.
Almost like they're going through puberty. Every single population all over the world, they're getting a little deeper every year, but very recognizable. You can go back 40 years later, listen and say, yeah, that for sure is a Chilean blue whale song. It sounds just like it was 40 years ago, but it's a little bit lower frequency now. But other species like bowheads, which are even more fascinating. In fact, I'd say blue whales are amongst the more boring singers. So Kate Stafford at Oregon State University has been working on bowheads up in the Arctic. And she put the hydrophone down, and the bowhead swim past, and the first one swim past, and it makes a very distinct set of calls. The next bowhead swim past, totally different calls. The third bowhead swim past, completely different calls.
Wow.
Dozens and dozens of completely unique calls, each made by one bowhead whale. Sometimes there might be a few making the same call. And if you go back the next year and you put your hydrophone down again, they're all making completely different calls. They're not making the same calls from the previous year. So Kate calls them the jazz singers of the whale world, because they're basically improvisational callers that make just completely different songs.
wow.
So those are the extremes. Humpbacks are pretty well known. They have these cultural revolutions.
Mm-hmm.
So you might have a population that sings the same song over and over and over again for 4 or 5, 6 years, and then all of a sudden, in comes Elvis singing a new song, and everyone's like, "Oh, that sounds fun!" And the next year, everybody's singing Elvis's song.
Yep.
The whole population just switched over. So they have a cultural revolution.
It sounds like the blue whales are overdue for an Elvis.
They're probably centuries overdue.
I don't know that I've heard blue whale calls. I definitely have not heard bowhead whale calls.
Yeah, I think I've heard a few blue whales, but it's been a while. But for sure, I don't think I've heard bowheads.
And are all the vocals from blue whales, are they all beyond the hearing range of killer whales? All of their vocals, or only some of them?
Yes, they all are. Now, they do make several different types of calls. I've been talking about the songs that you use, that the males make, that you can use to distinguish the populations, but they also do make a kind of a social call. They call the D call, that's pretty similar across all the populations that both males and females make. But all those calls are under 100 hertz. Many of them are down in the 15 to 30 hertz range.
Wow.
There are couple of populations that make a very, very faint sort of little precursor sound just before they make their song, that can be up to 500 hertz. But it's so faint that unless your hydrophone is basically right next to where you won't hear it.
Mm.
So it's very unlikely that a killer whale would be able to hear that at all. So yeah, so super, super deep. And there's an IMAX movie out right now on blue whales, and I helped assist a little bit with the science behind it. And the director said to me, "We're going to start off the movie with the sound of a blue whale call that's going to vibrate the whole movie theater." And I said to him, are we going to be able to hear that? Because if you play a blue whale call on my laptop, I can't hear anything. And he said, yes. IMAX has this amazing, deep style subwoofer and so on. And I was a bit skeptical. Anyway, I went to the Pacific Science Center in Seattle and watched this movie with my wife. And sure enough, when they played the sounds of the blue whale calls, the whole theater was just vibrating. That's more like a deep vibration if you've got a good enough subwoofer than it is something that you would think of as a song. So usually when people analyze the calls, they speed them up
Right.
10 times so you can hear them at a higher frequency.
That's fascinating.
I'm coming down to Seattle. I might have to see if it's playing while I'm down there.
Absolutely.
See it.
The IMAX movie, by the way, is called Blue Whales: Return of the Giants, and it's set
Okay.
in the Gulf of California and off the Seychelles. It's really amazing movie. Totally worth watching.
That sounds like a must-see.
Yeah,
I'd
really
have
does.
to make a special trip just for that.
So one of the things that you mentioned in the paper was that all of these whales, regardless of whether they're like in the fight club or in the flight club, can vocalize cryptically or can, be in that range where they would be acoustically cryptic to killer whales. But the species in the fight club do tend to vocalize kind of in the range of killer whale hearing. And is there something like behaviorally between the two types that behaviorally or physiologically, I don't know how we want to go about this, but that would potentially lend to that? Like why they wouldn't just choose to vocalize it cryptically if they could to avoid killer whales?
Yeah, that really puzzled me for a while. And as I said, I started off by saying, they can't hear blue whales, so maybe it's everything. And then as I started getting data, I kept on finding species of account, for example, that killer whales could hear. And until eventually I realized, wait a minute, they're sort of in these two groups, the fight club and the flight club. And it helps to take a step back and think about the fight versus flight division first. Because if you're a flight species, you want to be in a place where you can flee in all directions. You don't want to be stuck.
Mm-hmm.
And so one of the big distinctions in the Ford and Reeves paper was that the flight species, when they get ready to give birth and to mate and to nurse, when there might be calves around, they seem to disperse into open waters. So they'll go, relatively far away from the shore. They'll tend to be in a place where if they were attacked, they could just swim in any direction and get away. And if you think about what that means, it also means that you wouldn't want to be with an aggregation of your species. You wouldn't want to be in a big clump with dozens of calves, and mothers nursing and everything, and the killer whales could come find you and attack you. So you'd want to be kind of dispersed. So that kind of makes sense. But if you're a fight species, all the fight species, and particularly humpbacks and gray whales and right whales, tend to go places that are somewhat shallow water. There might be a calm, quiet bay. It's easy to defend yourself because the killer whale can't come at you from underneath. They can only attack you from one side. Mm-hmm. It helps to be in a group where you could come to group defense. So there might be lots of parents all hanging around in the same place. So a classic case would be, some of the lagoons in Mexico where gray whales come into a shallow lagoon. You all give birth in the same place. Great for whale watching. Or like Harvey Bay in Australia, where we went last year, where humpbacks gather en masse and with their calves and everything. And so if you're a fight species, you want to be in this sheltered, shallow water place. And if you're going to be in the same place every year, if the killer whales want to find you, you're going to be in the same place every year. They can find you. So you're not going to attract them with your calls because they know where you are.
Right.
They're going to target you. They would just target you every year.
Mm-hmm.
And so given that, perhaps there's not as much pressure to have a call that's cryptic. Whereas the flight species have got to be like ghosts in the water, like acoustic ghosts. They can swim silently and not be heard by the killer whales. Because if you could, then the killer whale could target one, find it, attack it, listen, find the next one, and attack it, listen, and find the next one. They could just move from one to the next, because that's what the calls are for, long distance calls to attract females, presumably.
It makes perfect sense when you think about it like that.
It totally, and it makes totally perfect sense, especially thinking about our personal experience with humpbacks and where they aggregate for calving and breeding. And it would seem like on its face, like what a great place for killer whales because there's so many calves, but that's not where they go when they are after calves for humpbacks or gray whales. They're getting them on their migration when they're separated and they're not in these big aggregations. It makes total sense from that standpoint.
Mm-hmm. Yeah, and there are all sorts of corollaries if this is what I say is true. And one of them is that if you're a humpback whale, you have a summer feeding area where you do most of your feeding for the year, then you migrate to some place that's safe to give birth and mate and nurse and so on and so forth. But you're not going to give birth until you arrive there and until there are enough other humpback whales around you to have group defense. So you're going to delay having your calf until there's enough protection around you. So you're going to have your calf later in time, where something like a blue whale, hey, as soon as you finish feeding and leave that area, you could have your calf. You'd have them on the migration route because you're moving away from where there should be any killer whales.
Mm-hmm.
You're not going anywhere predictable. And the further corollary is that if you're a humpback and you're in this sheltered bay with lots of humpbacks around you, you're probably not feeding, either no food there or very little food there. If you're a blue whale, though, you could be going somewhere and snacking. You could be snacking all the way on your migration route. You could be going somewhere where there's food in winter as well. You could be more like a hobbit than a humpback.
Like
multiple meals every day.
Yeah.
Well, it makes sense too, just the idea of why humpbacks migrate to where they go for birthing and calving, because it's just a much safer place for them to have their calves, and could be the evolutionary driver of why they started to migrate in the first place.
Yeah.
Yeah, absolutely. Yeah, there's actually, I'd love to say I invented that idea, but it actually has been published as an idea for why baleen whales migrate in the first place, because it's a bit of a mystery.
Yeah.
I mean, you're eating somewhere where there's lots and lots and lots of food. Why bother migrating thousands of miles to go somewhere else to breed and nurse and so on? And so one pretty strongly supported hypothesis is that they go places where there are fewer killer whales, both the fight and flight species. And if you're a killer whale, if you think about it, most mammal-eating killer whales are not targeting baleen whale calves for their primary diet.
Right.
They'll do it. Some of them do specialize. There are exceptions, but most of the time they're probably eating seals and sea lions and even dolphins. They'll eat almost any mammal, and so most of the time they're not specializing on large whales. So if the large whales just go somewhere else where there are no seals and sea lions and so on, then they're probably going to be much safer.
Yeah.
Fascinating. I would imagine it would be easier for killer whales to target baleen calves if they were having their calves in the feeding waters and they weren't all aggregated in a small area, and you just had cat moms and calves separated over feeding areas, it'd be easier for
Mhm.
killer whales to make them a more primary source of prey
Yeah, for
year
sure, for
round.
sure.
Mhm.
And actually, probably the most interesting case of all is in the Antarctic. So in the Antarctic, there are something like 30,000 killer whales in the Antarctic. So this is, I don't know, many, many times more than there are in the North Pacific or North Atlantic.
Right.
And so hordes and hordes of killer whales, obviously lots of penguins and seals and lots of whales there too. And some of the types of killer whales in the Antarctic do specialize on feeding on Mickey whales. And even the adult minke whales are not that big.
Right.
An adult minke whale is a lot smaller than a blue whale calf. That's a couple months old, and so you could totally see why minke whales in the Antarctic do all kinds of things to avoid killer whales. And one of them is that they never produce a calf in the Antarctic, and they never return to the Antarctic with a calf. So you almost never ever see a minke whale calf in the Antarctic. It's just very, 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 very rare. And yet we know that minke whales have very high pregnancy rates. We know that they give birth every 1 to 2 years, way more often than any of the other baleen whale species. Because whalers went and caught a lot of them and
Mhm.
found out how many of them were pregnant.
Right.
And almost everyone is pregnant. So we think that what minke whales do is they fatten up, feed, and they leave the Antarctic. They give birth, they wean the calf really, really quickly, maybe in 4 months.
Wow.
Then they abandon the calf and go back to go feed again. And they're not particularly great parents. So presumably the survival rate of calves isn't that great, but they produce a lot of them.
Right.
But how do they themselves stop being eaten by killer whales? Because the adults aren't very big. So yes, they consume really, really quickly, but they're not particularly big. Maybe they aren't very good at evading killer whales. And a colleague of mine who goes down to the Antarctic pretty frequently, listening for whales, did a study where they went down and they dropped something like 80 or 90 hydrophones. Every few hours, they would listen for whales. And when they got to the Antarctic, they could hear blue whales calling almost on every single hydrophone they put down. And blue whales call very loudly, very low. The sound travels for long distance. And they almost heard no minke whale calls at all. Right? So lots of blue whale calls, very few minke whale calls. And the kicker is this, that minke whales are 50 times more abundant than blue whale in the Antarctic.
It's fascinating.
Yeah, it's so interesting.
And this also explains to me why we don't see minke whale calves where we are here.
Yeah, I think in the 30 years I've been out here, I've seen one. I haven't even I didn't see it. There was one minke whale calf that was confirmed here, in the Salish Sea. We get a fairly not sizable grouping of minke whales, but sizable for anywhere on the coast out here of minke whales. And yeah, I've never seen a calf, and they're mostly female from studies. Huh.
Yeah, so it just suggests that wherever you see lots of minke whales is not going to be where they have any calves, because they must be leaving and going and dispersing somewhere maybe far offshore, or somewhere where lots of people don't go. And when they have their calves, they're basically like a submarine.
Yeah.
Stay silent, stay deep, don't make any sound, stay away from trouble. And for decades, nobody knew what these occasional weird sounds were in the ocean. People had hydrophones. Well, for a start, they didn't even know that the fin whales and blue whales were making calls. So that was the first mystery. As soon as the Navy put down hydrophones listening for foreign submarines, they heard this cacophony of deep frequency sound that they had to identify. But pretty soon they figured out, oh, there must be fin whales and blue whales and so on and so forth. But minke whales make the weirdest calls. There's a call called the Star Wars call and
Ah.
Biodac call, and they're just the boing.
Hmm.
They came up with it weird then because you would hear the occasional sound that was just totally bizarre, and you could never track down what was making it because presumably they don't make them very often, so you wouldn't know where the sound is coming from, and you wouldn't be able to track them down, just like killer whales couldn't track them down either. Whereas a blue whale or a fin whale, blue whales, Antarctic blue whales are going wah wah, wah wah, wah wah, like for hours and hours and hours. The perfect mansplaining song if you're trying to attract the woman somehow. And presumably the female blue whale, they're sitting around thinking, okay, fine, I should go find a mate. Oh, there's one, 200 miles that way, and there's one 400 miles this way, and that one has a beautiful baritone voice. I should go swim after that one, because they're very good at traveling long distances.
Sure.
There's no problem for a blue whale to travel a few hundred, kilometers. They're very sleek, very streamlined, very efficient at swimming, basically built for long distance travel. So, and then presumably they decided it's time, I'm going to chase after that one and meet up. So, the blue whales have there really are two reasons for them to call deep. One is that deep calls travel much further. And the other reason, presumably, is that they are avoiding attracting killer whales.
Just so fascinating.
It's absolutely fascinating.
Isn't that cool?
Can't wait for your book to come out so I can read all about this and more.
I hope to get that out in a couple of years. Taking longer than I thought.
They always do. I feel like been working on a book for years. But this kind of ties into your other paper. You released another paper recently about missing blue whale calves. Timing hypothesis explains the mystery of the missing blue whale calves. Can you kind of explain about that one? Because I found that just as fascinating as this. And I feel like they kind of tie into each other.
I was going to say, before, like when I was reading these before, they seem like two completely separate topics, but it now makes sense together.
Yeah. That paper was even more interesting. I was chatting to a colleague of mine, Richard Sears, who's one of the most well-known people in the world who works on blue whales, and he's been working in the Gulf of St. Lawrence and in some other places in the world on blue whales for almost 50 years. And every year he goes out and he has a group and they study blue whales in the Gulf of St. Lawrence on the east coast of Canada. And he sees blue whales there, every year, and they get photo ID and everything. And we're having this chat on a different topic. And he said, in 45 years here, I've only seen 35 blue whale calves. And I said that's astonishing. And he said, yeah, I don't know what's up with that, but I guess this population isn't, very productive. They're not producing any calves. And I'm a modeler and a population modeler, and I started thinking about this, and I thought, well, I wonder if this is a general phenomenon that we don't see very many blue whale calves, and I wonder why this is. And so, again, just like the first paper, I went and contacted a whole bunch of people and looked up a bunch of papers and said, hey, what do you see in your area? Do you see any blue whale calves? Looked up papers, and it turns out that out of all the sightings, on average, everywhere, people only see a mother-calf pair in about 3% of every sighting of blue whales, which seems to me very, very low, because I've been doing a lot of work on the modern whaling database, and I know that the pregnancy rate of blue whales is, they give birth about every 2 to 3 years. The pregnancy rate is maybe 40%, 30%, something like that, depending on the region. So to only see 3% of the population being mother-calf pairs seems super, super low. And I started thinking about why this might be the case. And my initial thought was, well, maybe they're giving birth in places that people are not studying them. I mean, who wants to go and study a blue whale in the middle of winter when they're all dispersed in the open ocean? when you could study them somewhere where they're feeding and they're all aggregated together and they come back reliably every year to the, more or less the same place. And that got me thinking about, well, that means the timing of their birth would have to be very, very specific because they have a 7-month period of nursing. So if you give birth, 7 months later, you still have the calf with you. And so if you're feeding 5 months of the year in summer, that means you basically would have to give birth as you leave the feeding area, the summer feeding area. You'd have to give birth and you'd have to wean as you get back. You'd have to wean your calf and stop nursing. And so I thought, well, how much evidence is there for this? And there are always exceptions,
Sure.
but generally that seems to hold true that if you were to go and study blue whales in the winter, you would see a much higher proportion of mother calf pairs than if you study them in the summer, when the proportion is even lower than 3% on average. And so it seems to fit this idea. Now, there could be other explanations, and the paper is basically like, here are a very wide range of hypotheses to explain this, and I tried to find evidence for some of them. Some of them you can discard, and some of them there's not much data, so it's really hard to say. For example, maybe as blue whale calves get older, they don't stay with their mother very much of the day.
Mm-hmm.
You might be seeing what just looks like a small adult that's actually a baby that the mother is off feeding, and so in some areas that might be true. So we're planning a follow-up paper that really delves into this in much more detail, but it does seem that just the timing of birth and weaning can pretty much explain the difference.
Wow. Yeah, it would have to be very specific to get that like 5 months worth of feeding in, which seems like such a small percentage of the year, to like be dedicated to feeding and
For
like
the
really
largest
packing
animal
it.
that's ever
Yeah,
lived,
yeah.
right? Wow.
Yeah. Well, I mean, bear in mind what I said about blue whales being hobbits, wanting to feed all the time, even in winter. A really cool paper has just come out from Australia where they put a very specific long-term tag on that allows them to detect feeding lunges. So usually when you track something with a satellite tag, the whale swims, in a directed migration route, and it sort of stops and moves for a few days, and you infer that it's feeding. It swims for a few days in a directed fashion and then stops and moves. But this time they could actually see when it was doing lunge feeding, diving down at a depth, recorder on the tag. You could see when it dived down deep, which they don't do when they're migrating. And you could see when it opened up because the accelerometer on the tag tells you when you slow down and speed up and change direction. And they were able to show that these migrating Australian blue whales, pygmy blue whales, actually stop and feed almost the entire migration route up to Indonesia. The whole way they're stopping, and every now and again they're diving down and feeding and coming back up, and diving down and feeding a few lunges and coming back up, even when you wouldn't detect it from the satellite movement data on the surface. You need the 3D, like, are you diving as well deep, or are you just doing sort of shallow migrating, surfacing, 20, 30 meters down? So yeah, they'll feed opportunistically whenever they can, and maybe that's part of their strategy.
So interesting.
Yeah. I mean, just shows you like how much like the advancement of technology and of these tags can tell us.
Absolutely. And it's interesting. I had just always assumed that blue whales had breeding grounds where they aggregated like humpbacks, but that doesn't seem to be the case.
Maybe for some populations they do, but nobody's ever come up with a nice aerial photograph of, look, here are 10 blue whales and their calves. Whereas, I can go to South Africa. I'm from South Africa. I can go to South Africa, and we were at a small game reserve called De Hoop, up on top of a sand dune, looking out at the ocean, and we could see probably 50 southern right whales, and I'm guessing at least 20 of them were just surface logging with a calf next to them. At any point you look out there, you can just that there's a mother and calf pair just hanging out close to shore in a nice shallow place. Some of them lobtailing or even breaching, but I don't know of anywhere where you can see an aggregation of blue whales with calves. I mean, there are places where you can see lots of blue whales, but they're usually feeding places,
Hmm.
or there are a couple places where they're a migration route. So Timor-Leste, there's a narrow pathway where all the whales migrate between Indonesia back to Australia, and they do come down there, and they do see mother calf pairs migrating down.
So interesting. I'm also thinking that, when the blue whales get back to their feeding waters, if the calf is there and it's 7 months old, it's not a calf that like of what we think in our mind. A 7 month old blue whale is probably not like oh, look at the cute baby.
It's astonishing how big they get, and maybe that's another adaptation to avoiding predation. You want your calf to get as big as possible, as quick as possible. Baleen whales have faster growth rates, both fetal growth rates inside and calf growth rates than any other mammal group in the world. Way, way, way faster than any terrestrial mammal growth. Even hippos and elephants and so on. Elephants have I think a 22-month gestation period,
Hmm.
and blue whales have an 11-month gestation period. And the blue whale calf is a lot bigger than an elephant calf. So the growth rates are just astonishingly fast. And so, a blue whale calf is bigger than most fight club species of adult.
Right. Wow.
Bigger than most, gray whales, right whales, bowheads, humpbacks. And in fact, the kind of interesting thing when you look at the size, because one of my graduate students, Zoe Rand, said, well, this isn't anything to do with killer whales. Have you considered it's just the size of the whale? And I thought, gosh, maybe you're right. Maybe minke whales are making high sounds because they're small, and blue whales are making low sounds because they're big. Maybe that just explains everything. And what's interesting is that, first of all of these whale species can make low sounds below 100 hertz, well below what killer whales can hear. If you plot the sort of peak sounds, the peak frequencies against size of the whale, there is a relationship where the bigger whales do make lower sounds than the smaller whales. So what's really interesting about that is that all of the fight club species make much higher calls than expected for their size. So there is a fight club size relationship,
Uh-huh.
that their calls are much higher than you expect for the size. But also, what I discovered was that all of the fight club species are in the middle in terms of size. So the ones that flee include blue whales and fin whales that are enormous,
Right.
and they include minke whales and Brutus whales that are tiny.
Hmm.
But the fight species are all in the middle. And maybe that's because if you get too big, you're not maneuverable enough to fight back. And if you get too small, you're not big enough to fight back. You have to have some kind of body mass to be able to fend off a killer whale. It was just fascinating to me. And then there are species that we don't know how to classify, but are probably flight species or similar. There are some enigmatic species like the pygmy right whale
Hmm.
that most people have never heard of. And I was like, oh, pygmy right whales. How do they call? I'll just find someone that studied them, and they'll know. And it blew my mind. I still can't believe that no one has recorded a pygmy right whale song and tracked it back to the animal that's producing it in the open ocean. The only time anyone ever recorded pygmy right whale calls is when a juvenile got stranded in a harbor in Australia for 2 months. And during that period, someone put a hydrophone down and listened. And I think it was about every hour, they made a couple of sounds. And that was it.
Wow.
So, these pygmy right whales are truly the submarines of the ocean. They hardly ever see them.
Yeah.
I think there are plenty of them, especially around Australia.
Hmm.
But they surface very cryptically. They don't surface very long, and they don't make any sound, so you really can't track them down. So maybe their adaptation is to be just silent always. I don't know how they find each other, but
That's
Yeah.
amazing.
And we know they get eaten by killer whales because a colleague of mine, a very person very dear to my heart, who passed away a few years ago, Peter Fast, recorded a case of a killer whale stomach containing the baleen from a from a pygmy right whale.
Wow.
We know that killer whales eat them.
Just so many questions, right?
Yeah. Well, and so many layers to whale research, right?
Right.
Yeah, this has been the most fascinating project I've worked on. It started off with the spark of an idea, and the best thing about being a scientist is that sometimes you just get an idea from almost nowhere, and if you chase it up, you start unraveling all these interesting bits and pieces that come out. The best part about being a scientist, for sure.
Yeah, and then I always find that it leads me to questions I didn't even consider, before I was unraveling this and kind of looking at something else, and then all of a sudden there's all these other questions that I never even considered. So it's just wonderful.
Yeah, exactly. And it's sort of, as I went down the pathway from, oh, they can't hear blue whale, to maybe they can't hear everything. Oh, wait, seems like they can hear the flat species but not the fight species. But wait a minute, there's some exceptions. Why can they hear minke whales? A white gray whale's call low, and so on and so forth. I realized that the exceptions were often along this axis of they might call at a different frequency, but they're calling very, very quietly. So it's not just the frequency you call out, it's also the volume, the energy you put out, the sound energy you put out that makes a difference. And so something like a minke whale that does make high frequency calls, they don't call very often, and they call very quietly. And those two things together mean you really still can't hear them more than maybe 1 kilometer away. And probably if you're within a kilometer, you can probably hear the sound of the blow or the splashes or other cues in addition to the sounds they're singing.
Sure.
It's just so amazing that the world of whales is so much more complex than
so much bigger.
Yeah, than what we think about, or what certainly what you see at the surface. There's so much more going on.
Yeah, Roger Payne, this is a pretty famous anecdote. Everyone knows Roger Payne. He was the one who first discovered the sound of humpbacks and their amazing, intricate songs that go on for, tens of minutes, and ever-changing, beautiful songs. And he was the one that produced this platinum award-winning album that was shipped out with National Geographic copies in the 1970s. More copies of that sold than any other natural history sound. Anyway, he said that you have to see whales as being groups that are not together in terms of sight or distance, that they are gathered together in terms of sound. So as long as they can hear each other, maybe they're one cohesive group. So instead of a whale herd, they're a whale herd with HEARD, so that maybe blue whales are communicating with themselves across, he said, across ocean basins, maybe not quite that far.
Sure.
So fascinating.
We talk about that. We do talk about that because, I think sometimes people have a hard time, on kind of comprehending how different animals and beings, interpret the world. And we talk about whales being very acoustic animals, and this sense of place maybe not being such a physical place like it is for humans, but being, kind of a soundscape and being connected through that, acoustic environment.
Yeah, for sure. Yeah, we see the world mostly through sight, and I think whales see the world mostly through sound. Of course, the toothed whales are even more so. They're using sonar to detect objects and so on and so forth. And they have their own adaptations to killer whales, which is a whole other story.
Well, maybe we'll have to get you back on to talk about them.
Someone's already written a paper on that. That's all done. They basically either call super high, or they don't call at all. So they have cryptic whistles, or they call higher than the killer whale frequency.
Yeah, and we talked about that with Dr. Cindy Elliser last episode. That'll be coming out here shortly. She studies harbor porpoise, and so she was saying they're on the opposite end as the blue whales, right? They vocalize above killer whale hearing.
Yeah, which is really cool. And some of them, some of the toothed whales, like the beaked whales, some of the beaked whale, they'll dive synchronously, so they'll go down. And beaked whale could stay. They can go down. Well, I forget. Is it 2,000 meters? It's incredible. They can stay down for an hour or more.
Yeah, I think some of them almost 4 hours. I think now.
Yeah, just completely astonishing what they can do. And so they'll go down, but now, of course, as they're coming back up again, they're now out of breath, pretty much easy targets for killer whales.
Mm-hmm.
And so when they come back up again, they do so silently, and they sort of come up at an angle, so they surface far away from where they went down. And perhaps that too is some sort of adaptation, so they can't just be nabbed at the surface. And killer whales do eat beaked whales, which I find kind of astonishing.
Yeah, I spend a couple months every year down in Southwest Australia in Bremer Canyon, studying the killer whales there that eat the beaked whales, and it's been fascinating. These last few years, I've been down there for a few months doing behavioral data collection on them, and
they love their beaked whales down there.
Yeah, I just think that's incredible. I mean, given how hard it is for us to come across beaked whales and identify them and so on, it's amazing that the killer whales are very intelligent.
Yeah,
very intelligent species and pass on all their methods. So
incredible. Yeah, the only time I've ever seen in person seen beaked whales were on killer whale predations.
Really? Also in Australia?
In Australia, yeah, in Bremer Canyon.
Wow.
Yeah, I think the 5 years I've been down there, I've had three sightings of beaked whales that were not being pursued by killer whales.
Oh gosh.
It is.
So sure, once they're spooked, then they can't dive as deep.
Yeah. It seems like once they're spooked and once the killer whales are kind of on them, usually they get them subsurface, like you said, like they're coming up from a dive, they're, drained, and the killer whales try to intercept them before they can get a breath. But once they get them to the surface, if they are being pursued, they are keeping them at the surface and making a run.
Yeah, you'll see killer whales go underneath them to prevent them from diving again.
Wow. Yeah, they're very efficient hunters and killers, killer whales.
Yeah, absolutely.
Well, thank you so much for joining us. We always ask our guests what, kind of an impactful whale experience is. If you have one you'd like to share, great. And if not, no worries either. But we always kind of like to close with that.
Well, of course, I'm a modelist. I don't spend a whole past sea. It's an unfair question. But actually, I went down to Chiloé Island, which is just the most beautiful place in southern Chile. And a colleague of mine, Barbara Galetti, works down there. And she took me out. And her colleague, Alta Cabrera, they took me out a couple times. And I'd banked on being down there for a week, so I'd have enough chance to see some blue whales, because there are lots of blue whales out there. But the conditions on the west coast is open ocean. It's super choppy and big waves, and you go out in a tiny little open boat, just a outboard engine and nothing else. And and so it took until the very last day and the very last hour of being there before we finally, okay, let's go back. And as we turned around to come back, the blue whale surfaced right in front of us.
Oh,
so it was a super special occasion for me.
Yeah, absolutely.
That's awesome.
Well, thank you again so much for joining us, for chatting about your papers. If you publish more, if you ever want to come back on and talk more about blue whales, we are always game to have you on and talk about them, because I don't think they get enough love. I've learned so much already. So yeah.
Thank you so much. This has been fascinating.
Thank you so much. It's been really great to talk about my favorite topic.
Well, anytime.
That was cool.
That was really, really cool. I know. I think I've throughout the conversation, I'm just saying the same thing over again. Wow.
I know it. I learned so much, and like I said, the two papers seem totally separate, and then now it makes sense that they really are related.
Yeah, potentially related, right? There's just so many more questions.
Totally. And I understand a lot more now. And like two things that stand out from the conversation and what it's driven in my thoughts. One is I've never really thought about how much must be evolutionarily driven because of killer whales. As somebody
potentially,
who's
right? Yeah.
Yeah. As somebody who's such a big fan of killer whales, it's like, wow, all of these other whale species and their evolution, what they do is driven in large part because of these predators.
Yeah.
Most likely.
And I mean, you think of it broadly, like any species, right? They're going to kind of develop adaptations or evolve to avoid being prey.
Of course. But I just don't think about that.
Right. Because you're stuck on the apex predator, Jeff.
Exactly. The other thing that really stands out to me, the idea of the Fight Club and Flight Club species based on what we see here, just in our limited experiences of what we've seen with humpbacks, sometimes grouping up and being the aggressors over killer whales, kind of explains that. And then seeing several cases of minke whales fleeing killer whales. One time we saw them get caught, but we've seen multiple times where they're on their flight and they get away.
Yeah, actually, while we were talking about that, I was thinking about that minke whale chase with the T-18s and the T-65Bs, where they like found that minke whale over by Victoria and chased it for 15 miles over to the south end of Lopez.
Crazy
kind
fast.
of like not Middlebank, excuse me, MacArthur Bank area, where there were other minke whales like actively feeding. And it makes me wonder if it was like, yep, I know that there's other minke whales there, so I'm gonna run as fast as I can and see if I can get in there and
get away.
And it did, right? It went in there, dove, and from photos we have of the chase prior to that and after, we know it was a different minke whale, and the killer whales had already been running for 15 miles, so they were tired and gave up shortly after.
I will never forget seeing old T-18 in the lead.
Oh, yeah, flying.
Porpoising after the minke whale, and the minke whale was porpoising. And at one point, she was maybe 100 yards behind the minke.
Yeah.
And then they just gave it up.
Yeah, her and T-65B were in the lead, and the kids were like behind, kind of going, okay, we're hungry now.
Remember we lost the kids for a while because they stopped. They just started socializing and were waiting for dinner.
Yeah. Yep.
But what a really cool conversation. And yeah, I never realized that there weren't these aggregation of blue whale moms and calves. And never really thought about how big a 7-month-old blue whale calf would be. Yeah. It's just really, really interesting conversation.
I think we're going to have to make a trip down to Seattle to see that IMAX film.
Definitely. And things are heating up here on our tours. We've been running every day for a while, seeing lots of killer whales. So come out and join us on one of our tours with Maya's Legacy Whale Watching.
Yep. And next month we'll have our photography workshop, May 17th and 18th. So there are a couple spots left. So give us a shout if you want to join us for that. It's 2 full days on the water. We cater lunch. Have a lot of fun. See how many whales we can find.
Yeah, if you were interested in those workshops, email us at afterthebreachpodcast@gmail.com. If you want to book a whale watching tour with us at Maya's Legacy, you can book that at sjiwhalewatch.com.
Yeah, we'd love to have you out. Make sure if you do join us that you let us know that you're a podcast listener. And as always,
stay safe out there.